Okay, for page 21, label your paper complex numbers. You're going to want to cut the sheet along the dotted lines on the inside. You'll see them, they're horizontal. Once you cut them, you'll be able to fold your paper, having 4 separate tabs here, labeled imaginary numbers, complex numbers, how to graph them, adding and subtracting and multiplying complex numbers, and complex conjugates and dividing complex numbers. We're actually going to save this tab for class with me because it's a little bit more difficult and I want to be able to explain it in class. But we'll do the other 3 tabs together. So this is what your page 21 foldable will look like once you paste it in there. Take a minute now to pause the video if you need to. Alright, so when you open up your first tab, it talks about the imaginary unit I. So we have talked in the past about not being able to take the square root of a negative number. For example, the square root of 4 is 2, but we would always say that the square root of negative 4 had no solution. Well, they finally decided that they were going to create a solution for square root of negative numbers. So in order to do that, they first had to come up with a letter that would go with that, which in this case they call I. And so I then is defined as the square root of negative 1. So this is going to be under imaginary solutions, not as in fake, but in the imaginary unit. So in this case, we can now take the square root of negative numbers, not using real numbers that you've been used to, but imaginary numbers instead. So if we look at this first example, the square root of negative 4, technically we would say that this had no solution, real solution. It has an imaginary solution instead. So what I'm going to do is I'm going to actually break this up into 2 pieces. I'm going to break it up into the square root of 4 times negative 1 instead. What that allows me to do is be able to break this up using one of your Algebra 1 rules regarding square roots. You can give this square root to both the 4 and the negative 1. So now when you take the square root of each of these individually, the square root of 4 is 2, the square root of negative 1 is I, so therefore our solution is 2I, which now means we have a solution for negative numbers. Whenever to a square root, we call them imaginary numbers. In this case, the square root of negative 4 is 2I. For the next one, the square root of negative 45. 45 itself is not a perfect square, but it does have one inside of it. That one is 9. So I'm going to break this up into 3 numbers now. The square root of negative 1 times 9 times 5, all under the radical. I'll then break this up into 3 separate square roots. Square root of negative 1 times the square root of 9 times the square root of 5. The square root of 9 is 3, the square root of negative 1 is I, and then the root 5 I can't do anything with, so my final answer is 3I root 5. By default, they typically write the whole numbers first, or integer numbers first, then the I and roots will go last. Just to note, the square root of 2 with a negative out in front is not the same thing as 2 times the square root of negative 1, and that's just based on placement of where it is. The negative on this first one is going to be on the outside of the radical, so it has a value of about negative 1.4-ish, but 2I is actually the square root of negative 2, and that is not the same thing as the real solution, negative 1.4-ish. Now, the square root of negative 1 is equal to I. We can square these, so I squared would be the same thing as the square root of negative 1 times the square root of negative 1, which turns out to be negative 1. So I squared is negative 1. We can talk about this in class, what I cubed would be and I to the 4th would be, but we'll talk about what's going on with that in class for this part. Okay. On the next tab, it looks like this. So as a complex number is a number that can be written in the form a plus bi, where a is the real part and bi is the imaginary part. So we have a new set of numbers called complex numbers. All numbers are going to fall into the complex numbers. And so then from there we have real numbers, which are going to be a subset of that, and then imaginary numbers and so forth. So the complex numbers, every single number, whether it's an imaginary number or a real number, belongs to the complex number. This is the biggest set that you can have. In your Algebra 1, your biggest set was the real numbers. Well, now the complex numbers are even an even bigger set of that, which includes imaginary solutions as well. We'll talk about more that more in class tomorrow. All right, so in order to graph them, we have an XY grid. The X part, or the real part, is going to go on your x-axis. the imaginary part is going to be graphed on your y-axis. So the nice thing about this is that it actually works just like an xy coordinate does. So anything that deals with the imaginary part is going to go up and down. Anything that deals with the real part is going to go left and right. So for example, 2 is the real part of the complex number 2 plus 3i. 3i is the imaginary part. So what I'm going to do is on the real number axis, which is the horizontal axis, I'm going to go right 2. On the imaginary axis, I'm going to go up 3. And so here is a dot for where 2 plus 3i would be located. If you will, go ahead and pause the video now and see if you can do the others down at the bottom where it says graph. And so for this first one, I went ahead and labeled these A, B, C, and D to make it a little bit easier so I don't have to write them out. So I'm looking here at 3. So 3 doesn't have an imaginary part, so it's labeled as 3 plus 0i. Well, that means on the real axis I would go right 3, and on the imaginary axis I would go up 0. So I would plot that here at, it would look like 3 comma 0 on an actual XY grid. But it's 3 plus 0i, or just plain 3. Letter B I've labeled as 2i. This can be rewritten as 0 plus 2i, so the real part is 0. 2i is the imaginary part. So on the real axis, left and right, I'm going to go no units. But on the y-axis, or the imaginary axis, I'm going to go up 2 units. So this would be the position of 0 plus 2i. Letter C I've labeled as 2 minus 2i. On the real axis, I'm going to go right 2 units because 2 is the real part. And negative 2i is going to be the imaginary part. So I'm going to go down 2 units. So here is going to be 2 minus 2i. And last one I call D, negative 1 minus 3i. Negative 1 is the real part, so I'll go left 1 on the real number axis, and I'll go down 3 on the imaginary part for negative 3i. And this is where that one would be graphed. So it's pretty easy. It works just like an XY grid, the X being the real numbers part of the complex number, and the Y being the imaginary part. And then for the last tab, we're going to be talking about adding and subtracting complex numbers and multiplying them as well. So when you're adding and subtracting, you're going to combine like terms just like you would have learned in Algebra 1. So the real parts will be added together and the imaginary parts will also be added together, and then you'll leave it as the real part plus the imaginary part. So for example, 2 plus 5i minus quantity 3 minus 2i. The first thing I'm going to do is I'm going to drop that parentheses by distributing a negative 1, so that it becomes negative 3 plus 2i. Positive 2 and negative 3 are the real part. That's part of my like terms, so I'll add those together to get negative 1. Positive 5i and 2i is part of my imaginary part, so I'll add those together to get 7i. So this value right here, when simplified, becomes negative 1 plus 7i. Number 2, when you're multiplying your complex numbers, you're going to want to use the distributive property. So what you're going to do is you're going to multiply i's just like you would do any normal variables, and you're going to multiply numbers with numbers. An expression is not simplified if I has an exponent other than 1. So for example, if you end up with I squared, I cubed, I to the 4th, you do have to simplify it so that it becomes just plain I. So looking at this first example, when I go to distribute, I'm going to multiply my negative 10 and my 2 together because those are my real, that's my coefficients. And then my I times I will become I squared. So I end up with negative 20 I squared. Now this is not considered simplified because the exponent is not 1. So I'm going to rewrite I squared as negative 1. We talked about this on the prior tab. So we've got negative 20 times negative 1, which becomes positive 20. For the next one, we have two complex numbers being multiplied together. We would FOIL this just like we would a binomial times a binomial. So we would do 3 times 2 for the first, 2 times negative 5i for the outer, 3i times 3 for the inner, and positive 3i times negative 5i for the last. We would combine our like terms, your imaginary and your imaginary part here, negative 10i plus 9i is negative I. This would still not be considered simplified if I put an I squared here, so I replace that with negative 1. Negative 1 times negative 15 is positive 15. So when I add 6 plus 15, I get 21. And then my imaginary part minus I. So final answer is 21 minus I. For the last one, we've got negative 2 plus 3i root 2 all squared. First thing I'm going to do is I'm going to expand this. I'm going to rewrite it just as I see it, so 2 parentheses right beside each other, and I'm going to complete it like I do number 3. So if you'd like to pause the video at this point to try it on your own, you may do so. So first is 4. Outer would become negative 2 times 3i root 2. Well, you're only going to multiply the 3 and the negative 2 together to get minus 6i root 2. Same thing on the inner, you'll get negative 6i root 2. And then on the last, you'll multiply 3 with 3 to become 9, I with I to become I squared, and root 2 by root 2 to get 2. So when I put my two imaginary parts together, I get negative 12i root 2. This 9 times 2 becomes 18, but then my I squared has to be replaced with negative 1. 18 times negative 1 is negative 18, and then 4 minus 18 will become negative 14, and then I'll leave my imaginary part minus 12i root 2. For the last tab, we'll take care of that tomorrow in class. And that's it for page 21 so far.